All right, good morning, guys. This is KAP for Friday. Please start with this warm up, pause, and play when you're ready to go over it. Okay, so warm up says an isosceles triangle ABC. We know that the measure of angle A is 92 degrees, and we need to figure out the measure of angle B. Okay, with any geometry problem, I really like to start with a picture. It helps me visualize what's going on and label A, B, C. It tells me that it's isosceles, meaning two sides are the same, and we know that the measure of angle A is 92. So I'm going to go ahead and fill that in. We're trying to figure out what angle B is. Okay, so what's different about this problem versus some other ones is it doesn't tell us which two sides are the same. I know it's isosceles, so I know two of them are the same, meaning two of the angles are going to be the same measure, but it doesn't tell me which two. So I'm going to start with saying, okay, what if 92 and there's another one? Like, what if A and B are the same angle measure? Okay, so if I have 92 and 92 together, if I'm thinking about a triangle, this adds up to, that one adds up to 184. And is that going to be possible angle measures? No. Okay, we've talked about how the three measures of the angles in a triangle, they add up to 180. I'm already above that amount, and I haven't even thought about a third angle. So 92 is not going to be one of the congruent angles. 92 is sort of going to be that one that stands on its own, meaning that the rest, whatever is left after I take this away from 180, whatever's less, that's going to be split amongst the two. So if I call this X, I can also say this is X. They are going to be the two congruent ones. Again, A, I can't have that congruent to another one because it would add up to over 180. So the equation I'm looking at is X plus 92. Those three angles together will give me 180. We know that this is the same thing as 2X plus 92. Again, it stays equal to 180, and then let's solve. I'm going to subtract 92 from both sides. 2X is left, bring down that equal sign, math. It's going to give me 8, and that's going to give me 8. Again, I need to split. That's what's left of the 180, but I'm going to split it amongst the two angles that I'm figuring out. X is going to be equal to 44 degrees. So the measure of angle B, that's going to be 44. Again, C would also be 44. Together, that would make 180. Okay. Moving on, homework. If you're not at home, if you're not in class and the teacher can't answer your questions, go ahead and check that key on Canvas, of course, and then come to tutorials if you have any questions. I will go ahead and say tonight, this will be at the end of class, but I want to say it here at the beginning so we're all fresh and listening. There is a test review getting posted today in Aware for KAP students, and it will be due next Wednesday at 11:59, meaning that you'll have a test next week. So get started on that review this weekend. Probably most of the material is taught, so just do the ones you can, and then come back to whatever we learn next week, and then make sure you get that submitted. Okay, so today we're going to continue talking about area of shapes. Today we're going to be focusing on trapezoids. If you remember from our little family tree yesterday of quadrilaterals, we had two little stem offs. We had the trapezoids and we had the parallelograms. The difference between the two, trapezoids have one set of parallel sides, where parallelograms have two sets of parallel sides. So we're focusing on trapezoids today. Okay. Of course, you'll always have your trusty dusty star chart for your formula. I'm just going to do a little quick chat about how they got the formula, and hopefully you can make those connections to the parallelograms from yesterday. All right, so trapezoids, again, it all stems off of the base times height formula that we looked at yesterday, meaning that we can get the trapezoid formula from the parallelogram. So as we sort of see right here, whenever we find the area of a trapezoid, it can stem off of a parallelogram. So I'm going to first look at the whole parallelogram here. Okay, I notice that the height, even when I'm just finding one of these trapezoids, I notice that the height doesn't change at all. It stays the same. Okay, what's a little weird though are these bases, because when I look at the bases of a parallelogram, they aren't the same. Okay, or sorry, the bases of a trapezoid, they aren't the same. I noticed they are the parallel parts to each other, but they're different lengths. One of them's shorter, one of them is longer. Okay, so that's going to be sort of where some things are different in our formula. When I'm looking at the full picture of the parallelogram, I noticed that the base is actually like this one, the longer base part plus the shorter base part. So that base is going to be base 1 plus base 2. That forms the whole base of the parallelogram. Okay, again, that's still going to be times the height. The normal height hasn't changed at all. Then again, I'm just looking for this trapezoid, not the full parallelogram. So I also noticed that the trapezoid is only half of the full parallelogram. Okay, now if none of that made sense, it honestly does not matter. I just like to talk about how they got this formula. You'll notice on your star chart that this right here is the formula for the trapezoid. Again, they start with the whole parallelogram, base times height, but that base of the parallelogram is base 1 plus base 2. It's the two base lengths. That's what forms the whole base. The height stays the same, and again, we're only taking half of it. Now, if you did not understand any of that, the only things that I need you to take away is the base 1 plus base 2 part of the trapezoid. The bases are always going to be the parallel parts, okay? The parallel sides. The height is always going to be perpendicular, makes that 90-degree angles, and then the bases are going to be the parallel parts. Again, we're going to practice that, so just watch along, you'll get comfortable with it. So a parallelogram can be decomposed, broken down into two congruent trapezoids. So the area of the trapezoid is half the product of the height and the sum of the bases. So some unique facts about trapezoids. The two bases, again, are parallel. And we use that we just show those two lengths with base 1 and base 2. It doesn't matter which one's the shorter and the longer. It just matters that they are parallel. The height is that distance between the bases. And again, it must be perpendicular. Remember, that's our fancy word for just 90 degrees. It must make a right angle. Okay, so here's that formula. On the star chart, they moved the H to the end, but since it's multiplying, we know that order of multiplication doesn't actually matter. Okay, so here's another trapezoid note. When finding the area of the trapezoid, it is important to follow our order of operations. Is going to be a key thing, order of operations. Now you might be like, why, Miss Lytle? The reason is because we have some grouping symbols in here. It's going to be very important that you do the grouping before any of that multiplication. Okay, got to follow those order of operations. Okay, so we're first going to look at different ways that we can find the area of the trapezoid. Like if you see the formula on star and you're like, I literally don't know what any of that means, there's of course other ways you can sort of work around it. So I'm going to do those two methods first, and then we'll look at the actual formula. So the first one is going to be to decompose the trapezoid. Break it down into shapes you are familiar with. Okay, I'm looking at this one, and these dotted lines, again, are marking the height, but they actually help me break that shape down into things that I do know. Okay, I noticed that a trapezoid, in a way, it has this rectangle in the middle, and then it's got a triangle on each side. So what we could also do is break it down and then add those shapes in the end. Okay, so let's start with, if I did the rectangle. My formula, we always want to start with our formula, substitute and solve. The formula for a rectangle is base times height. Substitute in the values. The base of this is going to be 6 times the height is 5, and therefore the area is going to be 30 square inches. Okay, now I need to remember that I need to add the triangle parts to that as well. So I'm just going to start with that. I'm going to say, okay, a triangle is 1/2 base height. Okay, well, looking at these triangles, I notice that I have 2 triangles. I have one over here and I have one over here. But I also noticed that those 2 triangles are the same triangles. It's just double the size. Okay, 3 inches, 3 inches, and both of them have a height of 5. So there's a couple ways I can do this. I could either calculate one of these triangles and then multiply it by 2, or I'm gonna be super fancy. Oh, I can't do it. Give me a second. I'm gonna be super fancy and be like, well, that one's the same as the other one. Give me a second. I'm gonna try and do this. Let me see if I can work my magic on my smart board. I can move this one over and just make one large triangle. That's honestly what I'm going to do because I don't like to remember to multiply in the end or anything like that. I'm just going to calculate this as one big triangle. So if it's one big triangle with 3 on this side and 3 inches on this side, it's a total of 6 inches on the base. And again, that height hasn't changed. So I'm going to substitute that into my equation over here. Okay, so I'm going to say my triangle is 1/2. The base length of the whole thing is 6 times the height of 5. Again, I like to get rid of that fraction. I'm going to do 1/2 of 6 is 3. I like to cross them out to show that I've used them, and that's going to give me 15. Okay, I'm going to add those two together to get 45 square inches. Now again, I'm just going to take a quick second. If I had done just the triangle on its own, I hadn't combined them. This is a base of 3. If I'm just looking at one of these, it's a base of 3, height of 5. If I had done 1/2 of base times height, 3 times 5, that would give me 15. 1/2 of 15 would give me 7.5 for just one of these triangles. Then if I doubled it, this one is also 7.5. Again, that would end up with that same 15 that I did up here. It's just a matter of what you like to do. Okay, so again, each one of these triangles was 7.5. This in the middle was 30. I combined all of those. I combined 30 and then the total of 15 together to get 45 square inches. Okay, that is one way to do a trapezoid. In case you ever forget the formula or don't know what the formula mean, you can always do that. Okay, I want you to go ahead, take a look at number 4. See if you can break it down, decompose it into shapes. There is something different about this one, so be careful, but then pause and then play when you're ready to check. Okay, so on this one, again, I notice I can break this down into a rectangle and a triangle. Now, what's different on this one is that there's only one triangle that it gets broken down into. Okay, so again, I'm going to do that decompose method. I'm going to start with the area of the rectangle, starting with my formula, base times height. For this rectangle, the base is 6 and the height is 9. The base 6 times 9, that's going to give me 54 for the area of the rectangle. So I'll go ahead and put that there. And then my triangle, that's going to be 1/2 base height. Always start with that formula because a lot of people will forget this 1/2. Ooh, okay, something different on this one. Okay, so the triangle, again, is this piece right over here. That height, 1/2. The base is a little weird. I know the height is 9, but the base, this tells me that this whole thing is 10 units, but it doesn't tell me just how much this is. So I sort of have to puzzle it together. I know that this piece is 6, meaning that this rectangle is also 6 for this part. So if this is 6 and the whole thing is 10 from end to end, that means the remaining part, that 4, is what the base of the triangle is. So the base of the triangle is 4. Again, the height stays the same. It's still going to be 9. Okay, and then let's solve. I know 1/2 of 4 is 2, and then 2 times 9 is 18. Now don't forget, you need to add those together, 54 plus 18. That's going to give me 72 square units. Okay, again, I didn't need to multiply this triangle by 2 because there was only one in this case. This is still a trapezoid because it has one set of parallel sides, but only one trapezoid. Okay, so that's an alternate method. Then, of course, we can always use our formula from our start chart. We want to make sure you can just do either one, whichever you're most comfortable with. Okay, so starting with our formula, then we substitute and solve. I'm going to write that formula just a little bit bigger. The area is equal to 1/2 base 1 plus base 2 times the height. Okay, let's look at this trapezoid. Okay, remember the bases are always going to be our parallel sides. So 11 and 14 are our 2 parallel sides. So I'm going to substitute in. It is equal to 1/2 base 1 and base 2. It doesn't matter which one is which. So I'll say 11 plus 14. My height needs to be perpendicular right here with 8. Again, a key thing with the trapezoid formula is you must do order of operations. You have to add first. 11 plus 14, that's going to give me 25 times 8. Again, I try and get rid of this fraction if I can. So I'm going to do 1/2 of 8. That's going to give me 4. I cross them out to show that I've used them. And then 25 times 4, you got it, is 100 square units. So you can go ahead and try this one. Pause and play when you're ready. Okay. Again, got another trapezoid, 2 parallel bases, and then a height. So A is equal to 1/2 base 1 plus base 2 times the height. Substitute in my values. A is equal to 1/2. My 2 bases are parallel. 12 and 5 are parallel. 12 plus 5 times the height. Ooh, 7.5. I'm going to go ahead. I know who y'all are, so I'm going to go ahead and put that at 7.5 because not today, fractions, not today. Order of operations, 1/2 of 17 times 7.5. Okay, you might have solved this in a different order. This is going to be sort of up to you what you would like to do first. If you want to do the fraction first, decimals, like literally whatever. I'm probably going to go ahead and do this, but if you chose a different thing, you should still get the same answer. Multiplying by 1/2 is the same thing as dividing by 2. 17 divided by 2, that goes in 8 times to give me 16. I'm left with 1 decimal. 0 goes in 5. Okay, so I need to do 8.5 times 7.5. Oops, sorry. 8.5. Oh my gosh, my pen. Sorry, guys. Times 7.5, and let's multiply 5 by 5. 42, 0, 35, 56, 59. Add that together. We got 57.36. Sorry, my handwriting is a little rough there. 63.75 square inches. That is our answer. Okay, so I think I'm going to do one more with y'all, and then you should be good to go. The last one we're going to do is where we're working backwards, okay, to determine the missing height. This is one of the ones where it gives us the area, and we have to work backwards. Now, the pretty thing is we're going to give you that formula so you don't have to work. Actually, I'm going to do it. No, yeah, I'm not going to use this formula. I'm going to rebel. I'm going to use the trapezoid formula that's given to me on the star chart. This isn't given to me on the star chart, so I'm actually going to do it like I know it. Okay, always starting with my formula. A is equal to 1/2 B1 plus B2 times the height. Substitute in what we know. I know that the area is 108 is equal to 1/2 base 1 and base 2. Hey, look, they gave me my bases. So that's 12 plus 15. And I just don't know my height, so I need to solve for that. So I'm still going to approach this the same way as I normally do when solving it. I'm still going to add those two together. I'm going to do 108 is equal to 1/2 of, what is that, 27 times the height. I'm going to do this the complicated way. Well, you can do it either way. You can do 1/2 of 27. I'm actually... If you remember with fractions, to get rid of fractions is to multiply by the reciprocal. So actually, I'm going to, no. I'm going to do this the less complicated way. I'm going to do 1/2 of 27. 1/2 of 27. It's going to go in once. It's going to go in 3 times, 6. It's going to give me 13.5. So I have 108 is equal to 13.5 h. To get h by itself, I need to divide 108 divided by 13.5. I don't like this decimal, so I'm going to move it over, bring it up, add that 0. 135 does not go into 1, 10, or 108. Give me a second. Because I know the answer, I'm going to go ahead and say 135. Let's check and see if 8 times works. So that's going to give me 40, carry the 4. That's 24, 28. and that's going to give me 10. Okay, look, exactly 8 times 1080. The height of this trapezoid is 8. Okay, so that's definitely a spicier problem. You won't see too many of those. Just knowing how to solve for that missing variables. It's just like the two-step equations we've done before. Okay, so what you're going to do now, do the partner practice, check the key on Canvas, and then again for homework, you have like these problems on the back page and your test review. Please check your homework questions on Canvas and then get your test review done by Wednesday of next week. Have a great weekend.